Welcome, everyone, to this episode of Field Notes. I'm Brad Puffer on the Medical Office Communications team at Fresenius Medical Care North America and your host for this discussion today. Here we interview the experts, researchers, physicians, and caregivers who bring experience, compassion, and insight into the work we do every day. A new mathematical model published in the Network Open Journal of the American Medical Association suggests that pooled testing for COVID-19 offers potential advantages over individual testing in certain cases. Through this method, samples from many individuals are grouped together into one diagnostic test. A negative result quickly eliminates everyone in the larger group. Well, this model was developed by a team at the Renal Research Institute, which is the division of Fresenius Medical Care. This group has a mission to improve the outcomes for people living with kidney failure by furthering our understanding of new technology. Just a few days later, after the publication in the journal in late June, members of the White House Coronavirus Task Force said they were considering this pooling strategy to improve testing capabilities. And finally, on July 18th, the FDA approved the first authorized test for pooling. So why did the Renal Research Institute develop a model for COVID-19 pool testing? And how else is this important research division helping us better understand ways we can perhaps better detect the virus and treat the disease? Here to answer these questions and explore this topic with me more is one of the co-authors of the study and research director of the Renal Research Institute. Dr. Peter Kotanko has led the Institute for the past decade and previously served as vice chair of a department of internal medicine in Graz, Austria. Dr. Kotanko, thanks for being here and welcome to Field Notes.
Thank you for having me.
Well, I explained a little bit about what pooled testing is, but maybe you can explain further the actual process. How does this work?
The essence of pool testing is actually known for quite a while. In the 1990s, it was used for hepatitis B and HIV, but these were all very special use cases. Now, how does it actually work? So I'll give you just an example. Say you have 20 people and you would want to know if they suffer from COVID-19. One way to do this is to collect one sample per person and then test every sample individually. So in other words, this group of 20 people will result in 20 tests. Alternative approach, that's pool testing, is to do the following: to put all these 20 samples into one batch or pool and then test the pool. Now, if the pool tests negative, then within the limits of the test sensitivity and specificity, you can conclude that all these 20 subjects are free of COVID.
If you have 20 samples and it's negative, you eliminate 20 people. But what happens if it comes back positive? Now you don't know which one. How do you deal with that?
If the pool test comes back positive, then you would test each individual sample. That's the simplest form of pool testing. It's called TwoStage pool testing.
You already have that extra sample in hand?
Right. So you would not want to go back to these 20 people because you have an extra sample set aside in the event that the pool tests positive.
How does that offer advantages? I can see how you would eliminate a lot of people very quickly. Is that the point? Is this really best for large groups of people?
Yes, so it's really good for a large group of people where the prevalence of the disease is low. So say if you know based on epidemiology that in a given population the prevalence is less than 20%, 25%, 30%, then pool testing offers a higher efficacy. If the prevalence goes beyond 30%, then pool testing is not efficient. So what's the prevalence of the disease in the population of interest? And we have some good data around that. For example, in school classes where there haven't been, say, one case of COVID-19 in the entire school, then you could assume that the prevalence is less than 20% to less than 30%. So this would be a scenario for pool testing, or in a nursing home where one case has been diagnosed, but there are 200, 300, 500 residents. Then again, pool testing could be a very, very efficient method.
And as we're all looking to see how we might be able to reopen schools in the fall or have some semblance of normal, it seems like pool testing is potentially a way to start addressing this demand and this issue. How exciting was it for you to see just a few weeks after your study was published, the FDA approve the first test for use in pool testing?
I was just so surprised, I have to say. Pool testing is around for 3 decades. In hindsight, it's almost a no-brainer to do it. It was used already in some countries, like in China, Israel, Germany, and I guess also a few other places. But I was so surprised. I would have thought it might take much, much longer. I guess that's why it's called an emergency use authorization. The FDA and other federal agencies and well, the politics have understood that we just need to do more testing. And it's not just one test per person. It will be, I would think, repeated tests longitudinally. From my home country, Austria, for example, that certain groups in the hospitality business, they undergo now weekly tests. So I would think that something like this can also be implemented in some specific populations here in the country. And then you have to have tools that make testing highly efficient, also economically acceptable.
How did the Renal Research Institute see a link between potential pool testing and the work you do to advance technology and understanding for people with kidney failure? What was the tie?
We are responsible for a large number of patients. We as a company, RI as part of Fresenius Medical Care, we are responsible for close to 200,000 dialysis patients. And dialysis patients are a particular vulnerable population because they have immune deficiency, they have comorbidities, so they are much more vulnerable than the general population to COVID-19. And so we were really thinking hard, what could we do to improve patient outcomes on multiple levels? And one of those levels is, of course, the whole area of diagnostics. What can we do to speed up diagnosis in our patient populations? Of course, we are also working on several other projects related to COVID-19. And pool testing is actually attractive, I think, to dialysis clinics because patients are organized in dialysis shifts. Say a dialysis shift, say of 10 patients, 15 patients, 20 patients, lends itself naturally to a pool testing setting, provided that the prevalence is, as I said earlier, low.
And it sounds like you had the right team to gather to create this mathematical model. The collaboration was quite extraordinary across your team.
That's just RI's modus operandi. We have such a diverse workforce here at RI, be it MDs, nephrologists, of course, epidemiologists, mathematicians, biochemists, engineers, and so on and so forth. It's just our usual modus operandi that when there is a problem at hand, that colleagues from different backgrounds look at the problem and everybody contributes. So in this specific case, it was very clear the fundamental problem is a mathematical one, how to find the sweet spot for optimal pool testing. And the other question was, of course, but somehow we have to operationalize it. So this was a clear question for people versed in laboratory medicine and biochemistry. So this team formed very naturally overnight, literally, because there was a flurry of emails and text messages happening between, 7 p.m. and 2 a.m. in the morning. And then, next day, this group was consolidated and we knew what the path forward will look like.
Well, you mentioned a little bit earlier, this is not the only thing you're researching related to COVID-19. Tell us a little bit about some of your other research. I understand that you have a study you're working on right now around arterial oxygen saturation in COVID.
RI clinics and also some FKC clinics are equipped with a device that's called CritLine. And the CritLine is it's an amazing device, actually, that measures hundreds of times per minute hematocrit and also the oxygen saturation. In a patient who has an arteriovenous fistula or an arteriovenous graft, this oxygen saturation resembles the arterial oxygen saturation. So this is one piece of important information. So we have a way to get, during a treatment, data on the arterial oxygen saturation in certain patients. It's also recognized that COVID-19 affects in a number of patients the lungs. And it causes inflammation in the lungs, and this inflammation impedes the uptake of oxygen from the air. And as a consequence, the oxygen level in the blood drops. And a very good way to assess this oxygen level in the blood is to measure what's called oxygen saturation. In a healthy subject, say living at sea level, this oxygen saturation would be something like 97, 98%. Now, what we found actually is that in something like 10, 15% of patients, the oxygen saturation starts dropping, and in some cases, dramatically dropping before COVID-19 was even diagnosed. So it would drop, say, from levels of 92, 93, 94% within 2 days to levels of 85, 80, even 75, which is a dramatic decline. But it's, of course, a highly alarming signal. And because we have all those data collected through CritLine anyway, it provides actually a terrific opportunity to follow the arterial oxygen saturation throughout the treatment, but also between treatments.
The bottom line, if you could detect oxygen drop in some of our patients before they have COVID, what does that tell you, and how do you use this information? That's pretty exciting.
So we are now very careful when a patient's arterial oxygen saturation drops below 90% or declines by more than 5% point. In this case, our recommendation would be to test the patient for COVID-19 if there are no other clear reasons why the patient may have had this decline in arterial oxygen saturation.
As we talk about this various research that the Renal Research Institute is doing, whether it's pool testing or oxygen saturation, what do you hope will come out of all of these efforts?
In a few months from now, we are in a better spot when it comes to testing. Testing, in my mind, will comprise of a whole toolbox. It will comprise RT-PCR testing, individual patients, pool testing. It will comprise serology testing in certain situations. So this is one aspect to really increase the capabilities for testing, not just quantitatively, but also qualitatively. The second hope is, of course, that we are able to identify patients at increased risk for severe COVID-19 illness. And oxygen saturation may provide a means here. At the end of the day, I mean, it's really all about, can we keep our patients and staff safe? And if they contract COVID-19, are we in a position to diagnose this swiftly? Because early intervention helps. So this is, in my mind, the overarching goal here. And I think that the research we are doing here at the Renal Research Institute may contribute to achieving that goal.
Well, Dr. Kotanko, it's been really fascinating talking to you, and I wish you best of luck in all of this research and its effort to help our patient population and our employees, as you say, be ahead of this pandemic. Thank you so much for taking the time.
No, thank you. It was a real pleasure talking to you about this, and I hope that at the end of the day, in a few months from now, I said we will be in a better spot.
Well, thank you. And to our audience, you can find Field Notes on the Apple Store or Google Play, or right here at fmcna.com, where you can also find our annual medical report and other feature articles. We hope you'll be back and join us as we discuss more issues in the weeks ahead. Until next time, I'm Brad Puffer, and you've been listening to Field Notes by Fresenius Medical Care. Take care, everyone.